number of combinations of n distinct things taken R at a time, that is denoted by NCR, and its formula n factorial by n minus R factorial into R factorial. Suppose there are n things, and out of these n distinct things, suppose R things you have to select. Then you have to apply the formula NCR equal to n factorial by n minus R factorial into R factorial. And there are some properties on NCR. They are NCR, which is equal to NC n minus R, remember. And suppose NCR equal to NCS, if and only if n equal to R plus S. Next, you have NCR plus NCR minus 1, which is equal to n plus 1 CR. And NCR written as n by R, n minus 1 CR minus 1. These are the properties of NCR. Let us discuss the problems based on it. Suppose the question is, number of positive integers satisfies the inequality n plus 1 C n minus 2 minus n plus 1 C n minus 1, suppose less than or equal to 100. Only the positive integers satisfying this condition we have to find. We know that n plus 1 C n minus 2 minus n plus 1 C n minus 1, which is given as less than or equal to 100. And therefore, it can be written as n plus 1 n minus 1 whole divided by 6. And this is n plus 1 n divided by 2, which is less than or equal to 100. By the formula NCR equal to n factorial by n minus R factorial into R factorial. Using this property, you will get this result. Here, if you take n of n plus 1 whole divided by 6, what happens? N minus 1 first, and then minus 3, which is less than or equal to 100. Now you will get n of n plus 1, n minus 4, which is less than or equal to 600. Now, if you put n equal to 2, then 2 into 3 minus 2, which is less than or equal to 600. Next, if you write n value 1, you will get positive integers given. If you write n value 1, what happens? 1, 2, minus 3, which is also less than or equal to 600. But here, since n minus 2 and n minus 1 is given, n minus 2 must be more than or equal to 0, remember. Therefore, n must be greater than or equal to 2. So that just we need to take the value for n equal to 2 only. N equal to 1, which is not in this case. Why? Because n greater than or equal to 2. So that up to 3, 4, 5, and so on, up to 9. If you write n equal to 9, 9 into 10 into 5, less than or equal to 600. This is 450. Right? If you select n value 10, it goes to 900. So only up to 9, the values of n accepting the above condition, and hence 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 8 positive solutions are there. 8 positive integers accepting the above condition. Next, suppose the question is, in how many ways can a team three boys and 4 girls can be formed among 5 boys and 6 girls? This is the question. There are totally 5 boys and 6 girls. The question is, in how many ways a team of 3 boys and 4 girls can be formed? Out of 5 boys, you have to select 3 boys. And out of 6 girls, we need to select 4 girls as a team. So that the first work, selection of 3 boys from group of 5 boys, that is 5C3. Next, selection of 4 girls out of 6 girls, that is 6C4. Therefore, required ways equal to 5C3 into 6C4. The value of 5C3 is 10 and the value of 6C4 is 15, and hence you will get 150. Next, we go for another question. The question is, a committee of 5 boys or a committee of 5 members is to be formed out of 6 gentlemen and 4 ladies. The question is, how many ways it can be done? Number 1, first question, at least 2 ladies, in the committee included, at least 2 ladies included. This is first condition. Second question, the question is, at most 2 ladies included in the committee, right? Given a committee of 5 members that can be formed from 6 gentlemen and 4 ladies. 6 men, 4 ladies, right? And the committee of 5 members, the first question is, at least 2 ladies. So minimum 2, maximum 4 ladies. Men, ladies, and committee consists total 5 members, minimum 2 ladies. Maybe you can select 3 ladies or 4 out of 4. When you select 2 ladies as minimum, then what we get? Men should be 3. When you select ladies 3 members, men should be 2 members. And when you select 4 ladies, you have to select only 1 gentleman. So it gives committee of 5 members. So that out of 6 persons, you have to select 3. Therefore, required way 6C3 into next 4C2. Out of 4 ladies, you have to select 2 members. Next, this is 6C2 into 4C3, 6C1 into 4C4 it is. Therefore, 6C3 into 4C2, that gives 120. 6C2 into 4C3, that gives the result 60. 6C1 6, 4C1 4, that become 20. 6C01, 6C1 6, 4C1 1, so that it is 6. Therefore, 186 is right answer. Next, in which you have second question. The question is, ladies must be at most 2 is given. Right. Ladies may be 1, 2. At most 2 ladies. 1, 2 or 0. No ladies. 1 lady. Maximum 2 ladies. Next, this is about ladies. Next, gentlemen. When you select 0 ladies, 5 gentlemen. Here 4 and here 3 you have to select. So the team consists now total 5 members, right? So that ladies out of 4, 0. Next, gentlemen out of 6, 5. This is the case 1. Next, plus 4C1. Here it is into. Next, 6C4. Next, plus 4C2 into 6C3. Yes. 6C5 value 6. 4C1 value, 4C0 value 1. Next, 4C1 4. 6C4 15. Next, plus 4C2 into 6C3, that become 120. 6 plus 60 plus 120, that become again 186. This is the answer. Next question. The question is, find total number of ways of selecting 2 numbers from set of values 1, 2, 3 and so on 90, so that their sum is divisible by 3. This is the question. 1 to 90, there are natural numbers in a given set, and in which there are 3 multiples, 3 multiples plus 1 and 3 multiples plus 2. 3 types you will get. 3k multiples, there are 3, 6, 9 and so on. Next, 3k plus 1, 4, 7, 1, 4, 7, 1 also. 1, 4, 7 and so on. Next, 2, 5, 8 and so on. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. And total there are 90 digits. 3k first type 30, 3k plus 1 second type 30, 3k plus 2 third type also, you will get 30 numbers, right? That means here the condition is given as sum is divisible by 3. We must take 2 numbers from sum must be divisible by 3 is given, so that find the number of ways of selecting 2 numbers. you have to select two numbers and their sum must be divisible by 3. So from 3k itself, if you select two terms, any two terms, 3 and 9, their sum 9 plus 3, 12, divisible by 3. Whatever, any two numbers, if you choose from set of values of 3k, there are total 30 numbers in which any two, if you select, their sum must be divisible by 3. Next, 3k plus 1. From 3k plus 1 and from 3k plus 2. Select one from 3k plus 1 and then select from 1 from 3k plus 2. That also divisible by 7. The sum of those numbers is divisible by 7. Why? Because if you select 1, 5, 1 plus 5, 6, which is divisible by 3. And hence, in the first case, only from 3k type, if you choose 2 digits, then they are divisible by 2 numbers, then they are divisible by 3. Next, one from 3k plus 1 and the other from 3k plus 2, if you select, then their sum also divisible by 3. And hence the answer is 30C2 plus 30C1 into 30C2. This is also only one, right? Only one you have to select. Now 30C2 value, that is 435. 30C1 30, 30C1 30, 30 into 30, 900, and hence 1335. Total number of is 1335. Next. Next, suppose that the question is problems on geometry we will discuss. The question is 12 points are in a plane and given that out of 12, 5 of them are collinear. Total 12 in which 5 of them are collinear and the remaining non-collinear. Then question number 1. Then find total number of, question number 1, straight lines. Question number 2, triangles. Question number 3, quadrilaterals. Question number 4, pentagon. Given that total there are 12 points in which 5 are collinear. 1, 2, 3, 4, 5. Remaining are non-collinear. 1 and somewhere 2, 3. Non-collinear, I am going to mention here, 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 5 plus 7, 4 over, next it is 5, 6, 7. In this way, there are total 12 points, right? Now we need to find straight line. We know that passing through any 2 points, generally we get a straight line. But here, there are total 12 points. If you choose any 2, then you will get a straight line. But observe here, there are totally 5 points which are collinear. And if you choose any 2 points on this, you will get the same straight line. So that is repeatedly counted in this. So that I am going to remove, and you have to treat this as only one straight line. So 12C2 minus 5C2 plus 1. This is equal to 57, right answer. What I am saying, total there are 12 points. Out of 12 points, if you choose any 2 points, you will get the straight line. But particularly when the 5 points are collinear points, and here in this case, out of these 5, if you select any 2 points, that indicates common straight line. So here we are repeating in the counting, so that I am going to eliminate that 5C2. Next, but you have to consider that as only one line, so that plus 1 is needed to write in the solution. Next, the second one, number of triangles. See, total possibilities 12C3, but if the 3 points which are lying on the line does not form triangle, so that eliminate 5C3. 12C3 minus 5C3 gives the result 210. Next, third one, quadrilateral. All 4 points from the collinear points. Actually, there are 12 points, from which if you select any 4, then you will get a quadrilateral, and from which you have to remove first 3 points on the straight line and the other from remaining 7. That gives a triangle but not a quadrilateral. Next, plus out of 5, if you select 2 points on the straight line, and out of 7, if you select 2 points, yes, it is no 3 points on the straight line and 1 point on the other non-collinear point gives a triangle, right? 3 points here, but the 4th point somewhere. If you choose, it is not a quadrilateral. And if you totally choose the 4 points on the straight line, also that is not a quadrilateral, so that we have to remove. So 12C4 minus 5C4, 5C3, 7C1, that gives the result 420. Next, pentagon. Out of 12 points, if you select 5 points, that gives a pentagon, but the collinear points on which if you choose 5 points, then that is a straight line but not pentagon, right? And hence 12C5 minus 5C5 you have to write. And also, if you select 4 from straight line and 3 from and 1 from remaining, that is, you will get a triangle there. Next, if you choose 3 from triangle and 2 from other, that gives quadrilateral. Next, suppose if you select 2, yes, no need to write remaining, that's all. So that in these 3 cases, when you select total 5 points on the straight line, then that is not a quadrilateral. So I am removing 4 points on the straight line, 1 point on the other. That gives a triangle, right? 3 points on the straight line, 2 other. It gives quadrilateral. So you have to remember straight line, triangle, quadrilateral. So 12C5 minus remaining 5C5, 5C4, 7C1, 5C3, 7C2. Therefore, 12C5 value 792. Next, minus 5C1, 5C5 value 1. 5C4 into 7C1, that is 35. 5C3, 7C2 value 210. So finally, if you simplify this, you will get 546. Next, we will discuss another question. There are 4 different circles. there are 4 different circles. Next, 3 different parabolas. Next, 5 different straight lines. Are present in the plane. The question is, find maximum number of point of intersections. This is the question. See here, when a circle intersects with other circle, there exists a point of intersections. A line with another line gives the intersection. Maximum intersections 1. Here, maximum number of intersections 2. Suppose a parabola with another parabola intersects, then there exists at most 4 point of intersections. Next, a circle and a straight line. Maximum 2. A straight line and a parabola. Maximum 2. Now, a circle with parabola. Maximum 4. Let us see. Now the number of point of intersections. There are total 4 circles. Out of 4 circles, if you choose any 2, you will get 2 point of intersections. So 4C2 into 2 will become 12. Next, number of intersections by 2 lines. Out of 5, we have to choose 2 lines and their intersection is 1. Therefore, 5C2 become 10. Next, there are total 3 parabolas. Parabola if you intersect, then maximum number of intersections 4. Therefore, 3C2 into 4. Next, if circle and straight line intersects, then there exists 2 point of intersections, and there are clearly how many lines are there? 5 straight lines. And only 4 circles. 4 circles, 4C1. 5 straight lines, 5C1 into 2. Next, 2 intersections. 3 parabolas total and 5 straight lines. So 3C1, 5C1 into 2. In the last case, number of point of intersections is 4C1 into 3C1 into 4. Therefore, maximum point of intersections here 3C2 into 4, that gives the result 12. 4C1 4, 5C1 5 into 2, 40 it is. 3C1, 5C1 15 into 2, 30. This is 48. Therefore, total number of is 12 plus 10 plus 12 plus 40 plus 30 plus 48. That gives the result 152. Therefore, the maximum number of point of intersections 152 in this case. Next. Let us see a question. Let us create a scene from the film Bahubali. Assume that Devasena is trapped at the position capital D. What I am saying, we are assuming that a scene from Bahubali in which Devasena is trapped at D and Bahubali is at point B. Next, here the hero Bahubali decided to reach to Devasena. But in between them, the person Kattappa here. But Kattappa is positioned at K. Then find, the question is, then find number of different routes from Bahubali to Devasena, from B to D. And the condition, if Bahubali moves only up or to the right, and he must avoiding the position of Kattappa, right? This is the question, and tabular form is given in this way. Suppose that the position of Bahubali is here and the position of Devasena in this corner. In between them, the position of Kattappa here. But the question is, find the number of different routes from Bahubali to Devasena. If Bahubali moves only up in the upward direction or in the right side, and the position to avoid here to avoid the position of Kattappa, right? Right. Now here we can transform the above problem as Bahubali needs to move 5 horizontals, 1, 2, 3, 4, 5, and 3 verticals. By moving 5 horizontals and 3 verticals, B reaches to D. Whatever the way, let us observe first. Suppose here Bahubali decided to reach Devasena like this. This is vertical way, horizontal, vertical, horizontal, and horizontal, right? There are horizontals 5, verticals 3. So Bahubali to reach Devasena, he must move 3 horizontals and 3 vertical movements, right? If he choose another way, also if you observe 1, 2, 3, 4, 5, 6, 7, 8 in this way. Here in this case also horizontal, 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 horizontal. Total how many horizontals we have? 5. Next vertical. This one is vertical. So there are 3 verticals and 5 horizontals. To reach Devasena, Bahubali needs to move 3 horizontal movements and 3 vertical movements, right? So total number of ways here 1, 2, 3, 4, 5 verticals V, right? Total there are 8 letters, 8 factorial by. Next 5 horizontals, 3 verticals. They are repeated. Divide by 5 factorial, divide by 3 factorial. So 8 into 7 into 6 into 5 factorial by 5 factorial into 3 factorial. Therefore, 5 factorial gets cancelled. 6 is gets cancelled. There are total number of ways 56. Total there are 56 ways. But here one condition is there. The person should not move along the position of Kattappa, right? So that you have to remove from this. There are 2 ways from B to K. This way and this way you have to reject, right? So 56 minus 2 times. First, Bahubali to Kattappa, there are 2 ways. Next, Kattappa to Devasena. 1, 2, 3, 4, 1, 2. 6 factorial by total from Kattappa to Devasena, the movements I am going to write. That is total 1, 2, 3, 4, 5, 6 factorial divided by 4 factorial, 2 factorial. Therefore, 56 minus 2 into, this is 6 into 5 by 2. So that what we get? 30 divided by 2. This is 2 gets cancelled. 56 minus 30. It gives the result 26 is right answer. Next, we go for another question with the concept of circular permutations. We will discuss circular permutation. Arrangement of distinct objects around the circle table. There is a circle. Consider 5 alphabets and their linear as well as circular arrangements. There are A, B, C, D, E. There are 5 letters, 5 alphabets, and their linear as well as circular arrangements. Clearly, these 5 linear are different, but all these 5 linear arrangements are considered equal as one in a circle table, as there is no starting point and no end point in this case. Suppose if you have A here, B here, C, D, E. What you observe on a line, if you observe, it start with A, end with E. There is starting point and ending point. But in this case, in the circular permutation, where the alphabet starts, nothing but where is the end alphabet and starting starting alphabet, that we can't decide in the circular permutations, right? So 5 linear elements A, B, C, D, E. This one A, B, C, D, E. Next, start with B, B, C, D, E, A. Next, C, D, E, A, B. And then D, E, A, B, C. Next, E, A, B, C, D. Such type of B, C, D, E, A, C, D, E, A, B, D, E, A, B, C, E, A, B, C, D. These 5 linear permutations. Here, only one circular permutation, remember. There is no end point, right? So that n persons are arranged in a straight line. There are n different ways in which this can be done, whereas n persons at a round circular table, each circular arrangement will be 1 by n. Therefore, n factorial divided by n you have to write. Linear permutations, total here 5. Since there are 5 objects, you will get only one circular permutation. In the same way, here total 5 linear permutations equal to one circular permutation. And hence, if you select, there are n persons are arranged in a straight line. Therefore, n factorial divided by n, that gives the total circular permutations, that is equal to n minus 1 factorial. Here, each circular arrangement is 1 by n into arrangement of line. That's all. Each circular arrangement equal to 1 by n into linear arrangements. That's all. So that's why you'll get n factorial by n. That gives n minus 1 factorial. Here, the circular permutation, m clockwise and anti-clockwise, they are distinct. The number of circular permutations and different persons taken all at a time is n minus 1 factorial, remember. And in case of flowers, necklace, garlands, here, in that case, in case of flowers and garlands, there is no importance for direction, so that you have to write n minus 1 factorial divided by 2. Whenever clockwise, anti-clockwise sense are not distinguishable, then number of circular elements must be n minus 1 factorial divided by 2. Here, both the directions you have in n minus 1 factorial. But here, there is no two directions. For garlands and flowers, necklace, or a circular wire problems, you have to apply n minus 1 factorial divided by 2 is the formula. Suppose the question is, in how many ways 4 different flowers arranged in a circle? Then you have to write 4 minus 1 factorial. Suppose the question is, there are 4 flowers in a circular arrangement. The question. Formula n minus 1 factorial, nothing but 3 factorial is, it is clearly 6. Next. Suppose the question is, there are 3 boys and 4 girls. There are 3 boys, 4 girls seated around the table or around a table. The condition is no 2 boys sit together. No 2 boys sit together. This is the question. First, you have to arrange girls. There are 4 girls. 4 girls, first you have to arrange in a circular permutation in 3 factorial ways. And after that, in the remaining blank places, here, 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 and here, you have to arrange boys. automatically in between two boys you will get one girl. How many boys are here? 3 boys can occupy 4 gaps, right? So that is 4C3. In these 4 gaps, we have to arrange 3 boys, right? That is 4P3. 4P3 into 3 factorial. This is the arrangement of girls and this is the arrangement of boys. First on a circle, we are arranging girls. After arranging the girls on a circle, you will get 3 factorial. Next, in the remaining blank places, you can offer for boys, right? 3 boys in 4 blank places can be arranged in 4P3 ways. Therefore, required number of ways, which is equal to 3 factorial into 4P3. Therefore, 6 into 4P3 value, 4 into 3 into 2, 24 into 6. 144 is right answer. Next, we go for division of items into groups. Suppose there are m plus n plus p distinct items, and here, if you need to divide it into unequal groups, m, n another group, p another group. There are totally m plus n plus p distinct items, and divide into unequal groups containing m items in one group, n items in the other group, p items in the other group. That can be written as m plus n plus p factorial divided by m factorial, n factorial, p factorial. The condition m not, n not, p. They are different. Next, suppose if it is distributed to 3 persons, if it is distributed among 3 persons, then what happens? M plus n plus p whole factorial divided by m factorial, n factorial, p factorial into 3 factorial. Next, division of groups into equal size. Suppose that number of ways in which PQ different items can be divided equally into P groups, each containing P items. Sorry, Q items. Q, 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 and so on Q, P times, equal number of times. Here you have PQ objects. Then in this case, you have to write total PQ factorial divided by independently Q factorial, Q factorial, Q factorial, how many such times? P times. Next, you have to divide with 1 by P factorial. Why? Because the group containing equal size, and hence you have to write divide by 1 by P factorial. Next, if you distribute among P persons, then you have to write P factorial. When you distribute among P person, then P bar gets cancelled in this case. This is the process of division of groups, equal and unequal sizes. Next, Next, we'll discuss de-arrangements. Suppose there are n letters corresponding to n envelopes. N letters corresponding to n envelopes, right? Number of ways in which no letter goes its correct envelope. The question is, no letter goes to correct envelope. That can be written as n factorial into 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on plus minus 1 power n 1 by n factorial. This is the formula. Suppose only R things goes to wrong places. Then in this case, you have to write NCR R factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus and so on plus minus 1 power R 1 by R factorial. This is the formula. If R things goes to wrong place, out of n things, then n minus R things goes to original place. So here it is NCR or NCN minus R. Both are same. NCR is same as NCN minus R. This is the formula for de-arrangements. Let us discuss a question based on this. The question is, 5 students belongs to 5 cities. The question is, no one reached home. And we know that here the condition is no letter goes to its correct envelope, the meaning. So that the formula 1 by 5 factorial, 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. And hence, here it is outside 5 factorial, right? 5 factorial value 60. Next, 5 factorial is nothing but 120, right? This is 1 minus 1. Let's cancel 1 by 2, 1 by 6, 1 by 24, 1 by 5 into 4 into 3 into 2 into 1, 120 it is, right? And here it is 120. On simplification, it become 44. Next question. Suppose that the question is, at least 3 students do not reach home, or otherwise only 3 students do not reach home. That is the condition. Out of 5, you have to choose 3 into 3 factorial. Next, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. The question is, only 3 students do not reach home. Nothing but R envelopes must be goes to R letters goes to wrong envelopes, right? 5C3 3 factorial. 5C3 value here 3 factorial value 6. Next, 5C0 5C1 5C2 5C3 10. 1 minus 1 0, 1 by 2 minus 1 by 6. So it is 2 by 6, 6 into 10, 6 gets cancelled, you will get 20. Next, exponent of prime in n factorial we will discuss. Exponent of prime number p in n factorial. Suppose that the question is find exponent of 2 or find exponent of 2 in 100 factorial. This is the question. Exponent of prime in n factorial is defined by step of 100 by 2 plus step of 100 by 2 square plus step of 100 by 2 cube and so on 100 by 2 power 6. Here 50, 50 by 2, 25, 25 by 2, 12 point something, 12 by 2, 6 point something, 6, and then 3, and then 1 you will get, adding 75, 18 plus 4, 75, 22, that is 97. Therefore, exponent of prime in 100 factorial is exponent of prime number 2 in 100 factorial gives 97. So, in 100 factorial, it is 2 into 3 into 5 into something, but the exponent of 2 must be 97. Here something, some L, some K here, some L here. To get exponent of 3, you have to divide with 3 and again you have to divide by 3, 3 square, 3 cube and so on. Here the last one should be less than 100. Here 2 to the power 6, it is less than 100. No negative term. Here we will get positive terms. No need to get zeros or negatives. So here the denominator part must be less than numerator, remember. Thank you, one and all. We will discuss in the next session. Thank you.